work from the current slide. And we're ready to go. But let me make these last couple of announcements. I wanted to put them on Screencast-O-Matic so everybody can hear, anyone who might not be here. As I said, math team hasn't met this week. It probably won't because normally we meet on Monday, Wednesday afternoon. But we've run into some difficulties with that. But today I cannot meet because I've got a meeting on the Birmingham campus at 3 o'clock. Now, I'm here until 8 o'clock on Tuesdays and Thursdays in the evening, starting at 7:45 in the morning. It's a 12-hour and 15-minute days. I have to cut back on my office hours on Monday, Wednesday. Technically, my office hours, I'm supposed to be off campus at 2 o'clock on Monday, Wednesday. Seldom, if ever, will I leave at 2 o'clock. So if you do need me anytime after 1:55, 2 o'clock, catch me because I'll probably be here till close to 4:45, 5 o'clock, something like that, just because I've got too much work to do. I don't want to haul it home and bring it back, so I'll try to do it while I'm here. But today, I've got to go to the Birmingham campus for a 3 o'clock meeting. I don't know how long it'll last, but I'll spend the rest of the time there on the Birmingham campus. Now, I probably won't spend too much because I realized this morning I walked out of the house with something I needed to have left, and so I need to get back there sort of earlier today than normal. So I won't be there till 4:45 today. I'll probably leave shortly after the meeting. Let me find Frank. There he is. Frank's here. Anyone else come in since the call roll? Okay. Now, that really doesn't affect office hours, but it affects where I normally am on Wednesday afternoon. This one does affect office hours. Normally I'm on Birmingham campus Fridays, 7:45 to 11:45. Not this Friday, not next Friday. I've got, the doctor is trying a new round of treatments on me, and the first one I'll take this coming Friday, small dose, 300 milliliters, spread over 7 hours, okay? Can have reactions, so they're going to do it very, very slowly to make sure there's no reactions. So I'll be there from 7:30 in the morning until who knows how long. So hopefully, so I know I won't be on campus Friday at all. And then if that all goes well, then he'll try a full dose next Friday, and that'll be 1,000 milligrams, which still isn't very much, probably still spread over 7 hours. So I will be on my computer, grading papers, doing things until the Benadryl kicks in, and then hopefully I'll be sleeping. And that'll be me for the rest of the day pretty much. Well, hopefully I'll get up and do some more. Okay, but anyway, next 2 Fridays we'll not have office hours on the Birmingham campus at all. Okay. Now, any questions on anything we've done up till now? All right, we are in Chapter 4, Rational Expressions. Anyone want to remind me what a rational expression is? Say again? A fractional form, ratio, that's it, of what? Numbers would be a rational number. Rational expression would be a ratio of? Say again? Polynomials. Polynomials, rational expressions. Now, we introduced those in 4.1 that you slept through, right? No, I'm sorry, I didn't say that. In 4.2, we're going to, rather than simplify them, we're going to multiply and divide them. Rational expressions. Wait a minute. I thought the easiest operations were adding and subtracting. Isn't that what you learned first back in whatever? Why would they do multiplying and dividing first? Remember their rational expressions. What do you have to do when you add or subtract ratios of numbers? In other words, fractions, as you said at the very beginning. You have to have a common denominator. How about multiplying and denominating fractions? Not required. In fact, that's the easy one to do, and that's why we're multiplying and dividing first, because adding and subtraction is just a little more complicated. Not much, but a little bit. So that's why we're starting here. So we'll start, just as you suggested, starting with rational numbers or fractions, review how to do that. Then we'll multiply rational expressions. Then we'll divide rational numbers, then divide rational expressions, and then we'll simplify some problems that involve both multiplication and division of rational expressions. All right, so let's start with multiplying numbers, okay? And Peyton wanted to multiply numbers, so that's why she came in. Okay. These are rational numbers, though. So we define the multiplication of rational numbers in common fraction form. This is numbers now. We're going to get to expressions later. This way. If A, B, C, and D are any integers, as you were suggesting before, that means they can be positive or negative. Okay? Can be, some of them, 0. They can't be themselves decimals or fractions. They have to be whole numbers with positive or negative. So if A, B, C, and D are integers, but B and D couldn't be 0, why not? Look at where they are. They're in denominators. So they can't be 0. Then, when you're multiplying rational numbers, multiply the numerators, multiply the denominators, done. Now, there's a little bit more involved with that, but that's basically it for multiplying fractions. Okay? A little bit more is the first thing I would do, and what would you do? Look for common factors. Look for common factors. If something will go into A and D, take it out before you multiply it. Keep it as simple as you can. Be as lazy as possible, okay? Get rid of any common factors first, then multiply. And that's how we do rational numbers. Let's do a few. Okay, how about that one? 2/3 times 4/5. Second? 8 over 15. No common factor, you just multiply. Got it. How about this one? -3 over 4 times...
-15, 28.
That's it. There's nothing you can do to simplify. That minus can come out in front. Be sure you got it there. Again, look. Any time you have some negatives in there, count the negatives. If they're odd, the answer is negative. If they're even, the answer is positive. Okay? How about this one?
16.
Yeah, boy, tough one. Okay?
45. 45 over
Not 45, is it?
-65.
-65. -65 over 18. You got it. Nothing there we can simplify. That's how we multiply fractions. Any question on that? Josh had a question. He came in. All right. Anyone else come in since the call roll? Good deal. Okay. His eyes, or is that fuzzy? It is fuzzy. Okay. Where is the fuzzy? No, I've seen it before, but there it is. Did that get any better? Worse. Oh, good. Okay, let's try. Is that getting better or worse?
Worse.
Okay, stop there. Yeah. Okay. All right. That's a little better. Thanks. Okay. Multiplying numbers. Okay? We also agree, when multiplying rational numbers, to express the product in reduced form. Anytime you have a fraction, always put it in simplest form, reduced form. Now, that doesn't mean you have to write it as mixed numbers, but it does mean any common factors you take out. The following example shows some different formats to multiply and simplify a rational number. You tell me what you think you would do on that. Okay, yeah, the 4s can divide away, and that leaves you 3 over 7. Now, they wrote them together and then multiply. You can take them out early on. You can do 12 over 28, but then you have to reduce the bigger numbers. I like to do it small if it's possible. Here's, boy, they've done all the work for you here. 8/9 over 20 times 27/32. See first that 8 will go into 32, 8 and 8 one time, 8 and 32 4 times. 9 will go into 9 once, 9 will go into 27 3 times. Leaves you simply 3/4. If you can do it early, do it early. Okay? And do it in steps as you can. If you only saw that 2 would go into both of those, do them. Then you'll see another 2 and another 2 or 3 and another 3. Take as many steps as you need as long as you know what's going on. Common factor of 9 divided out of 9 and 27. Yeah, we did said all that. Any questions? All right. Now, what if you have some big old hunker numbers like you can start dividing away, and that's fine. Or you could do prime factorization. Now, that's a little more harder, I think. So I would start wiping away. What would you see could go into anything? Well, first, tell me something. What's the first thing you see in this problem? Negative. Negative. How many negatives is that? That means your answer is going to be positive. Very good. Okay, so forget about the signs. It's going to be positive. Okay? Now, what would you see some things that you could divide out?
25 and 65.
What? 25 won't go into 65. 5 will go into both. That would give, and sure enough, they're going to do that down here. 5 and 5 come out when you do the prime factorization. Okay? What else? 2 will go into this. How many times? 14 times it will go into this. 39 times. Okay? Now, what we hadn't done is how many times will 5 go into that? 13. Then 13 and 39. So you see, if you do them one step at a time and write down everything, you'll probably see it. Or you can always do prime factorization. Prime factorization here would be, what's the smallest prime number going to 28? 2 times, what's left over? Make 28, 2 times 14. What's the smallest prime number going to 14? 2. And what you have left? 7. That's a prime number. Okay, 65, smallest prime number going to that? 5. What you have left over? Someone said 13, right? 13, sure enough, there it is. Okay, the denominator, smallest prime number going to 25 times. Got it? And 78? 2 times. You said it earlier? No, 39. Smallest prime number going to 39? 3. Good. Okay. 3 will go into 39 how many times? 13 times. And now you see, sure enough, that was one I wouldn't have seen just looking at it. Because I don't know my 13 tables. Nathan does. And that's why he came in to help out. Okay, just a second. Let me get him here if I can find him. He may have left the roll. Let's see. There he is. Okay, he is. Okay, what'd you say?
On the first way, like after you got the 14 and the 5 and the 13 and 39, what do you do after that?
Okay, when we did it the first way?
Yeah.
Okay. Okay, let's actually do that. I was trying to cover it so you couldn't cheat. No, I'm sorry, you wouldn't be too lazy. David back there is lazy. I know he's really lazy. Okay, so let me get my pen activated here if I can find it. Boy, this thing is wacko today. It's not giving me the bar down here. Ah, there it comes. Wait one. Whoa, wait. All right. There we go. Now I got it. But it won't do anything. There. Okay. All right. So you said the first way we did it, we said, y'all told me 2 into 28. Well, first, minus times minus is plus. So take care of that. Okay. 2 will go into 28. 14 times. 2 will go into 78. 39 times. No more 2's in those. Next we looked here and said 5 will go into 25. 5 times. 5 will go into 65. 13 times. Now I'll look at that and say, anything else? Yeah. 13 will go into 13 one time. 13 will go into 39. How many? 3 times. Okay, now you multiply numerators. 14 times 1 is 14. 5 times 3 is 15. Sure enough, that's it. 14 15s. So you can always do it this way. Sometimes all that crossing out and stuff like this you might lose something. So be careful, that this 5 sticking up here, you don't miss that or something like that. But do what you can. Or you can always do prime factorization. It's sort of like, that's surefire. This way is, may save you some time. So, depending on whether you want to be certain or lazy. Okay, you choose. If you're good at it, you can be lazy and good. All right, any questions on that? Did that answer yours? Right. Is that what you're asking? Good deal. All right, any other questions? All right, or do prime factorization like they did. Now, that was, yeah, that's all there. Now we're going to multiply rational expressions. What's the difference in rational numbers and rational expressions? They're both rational, meaning ratio, divided, but what's divided in a rational expression? Polynomials. Okay, very good. Now, what do you think our approach will be? Pretty much the same as it was for simplifying rational expressions. What was that? What's your F word? Factor everything inside again, okay? Multiplication of rational expressions follows the same basic pattern as multiplication of rational numbers. Like up here, like what did we do before? We factored everything we could, okay? And that's why they introduced that technique, because that's what we're going to do in rational expressions. We multiply rational numbers in common fractional form. That is to say, we multiply numerators and denominators and express the final product to simplified or reduced form, but it's easiest first to factor out common factors, divide out common factors, okay? So here's an example. 3x over 4y times 8y squared over 9x. What might you do? Okay, this 3 and that 3 will go out. 3 will go in the 3 once, 3 will go in the 9 3 times. And then, as you said, the x's go out too. They've been dating. Okay, that would be x over x is 1. Good deal. That leaves us 1/3 down there. 4y. Okay, 4y will go into
8y.
yeah. Okay, how many times?
2y.
1 here, 2y up here. Absolutely. So that leaves a numerator of 2y, the denominator 3. 2y over 3, you got it. Now, they like these prime factorizations, don't they? They wrote this and gory, well, not as bad as they could have. They wrote this as 3. They took the numbers first, which is fine. 3 times 8. They could have written 8 as 2 times 2 times 2 if they wanted to. Times x times y times y. Oh, they just did y squared, okay? You could have done y times y. And then down here they did 4, which they could have done 2 times 2. 9, which they could have done 3 times 3. X and a y, okay? And then they go about dividing out. But why not do it here? It's just as easy to see. 3 will go to 9 3 times. 4 will go to 8 2 times. That takes care of the number part. The x's, x over x is 1. And here a y will go into y squared, y times. Why not? Okay? So it works. Then you multiply all your numerators together. There's a 1 here, a 1 there, so that's 2y. 1 here, 1 there, 1 there, so that's just 3. 2y over 3. I think the way you did it probably was a little faster, and it may have been easier to see. But this is a bit more surefire. And in fact, if you wanted to, do all prime factorization there. 2 times 2 times 2 for 8, and y times y for y, and 3 times 3, and 2 times 2. So you can do that if you want to. You do what you're most comfortable with to give you the right answer. That's what I'm looking for. Right answers. Okay? Here's some more. What's the first thing you note about that? It's going to be a negative because there's one and only one negative sign. So the final answer is going to be negative. Got it. Now worry about the numbers. What do you notice you can do? How? Okay, you got the minus sign out there, so you don't have to worry about that anymore. Okay? 4 going to 12 how many times? 3 times, okay? Well, 3 will go into both of those. 3 into 6 twice, 3 into 9 3 times. And you had a 3 down here, a 3 up there, so they go out. So numerically, you have 1 in the numerator, a minus sign with a 1, and down here you had a 2 here and a 3 there, okay? So that'd be a 6 in the denominator, okay? That's your numbers. How about your letters? What's that? Okay. Now I'm really lazy. I'm going to do a times a is a squared and take out one of those a squareds. That leaves me an a squared. So I know my denominator got an a squared. We had a, what was it, a 3 down there? 3a squared, okay? What else? Yeah, 1b here, and one of those b's goes, so you're left with a b there. So your numerator with a minus sign in front is just a 1. You got rid of everything else, and you had a 2a squared b. Now, you can do it this way if you see it better. You can prime factor it if you see it better. But however you do it, be careful with it. And they did the numerical factors first. They put the minus out front, which is a good idea. Then they did 4 times 9 up here. A times a is a squared, and b here, okay? Denominator, 6 times 12. They wrote that out. A squared times a squared is a to the 4th. Why multiply them when you're going to have to divide them back? I don't know. And just the b squared down there. Now let's take care of it, okay? 4 will go into 12 3 times. 3 will go into 6 2 times. And then the 9 3 times. The 3's and the 3's go out. So you're left with a 2 in the denominator for the number part. Minus sign up front, 2 in the denominator. Over here, a squared into a fourth will go a squared times. B will go into b squared b times. So up here, you got 1, 1, 1, and 1. So you just got a 1 there with a minus sign up front. A 2, a squared b. Does that make sense? Yes. The 1, because you see, 4 went into 4 one time. They didn't write it there, but they did. That's what you do when you're simplifying or dividing things out. You say 4 will go into 4 once, 4 will go into 12 3 times. They wrote the 3, they didn't write the 1. Here they said 3 will go into 6 twice, 3 will go into 9 3 times, but then you have a 3 here and a 3 there, so that would be a 1 here and a 1 there. A squared will go into a squared 1 time, and a squared will go into a fourth a squared times. B will go into b 1 times. So you see, so what they do, just like, they don't have one on here, but just like if you have 1 as a coefficient, you usually don't write it down. So when they're dividing out, they usually don't write down the 1s. I think you should write them somewhere so you see where it came from. Does that make sense? Okay. All right. And same thing with the power. If you have this a is to the power 1, but you see you don't usually write down the 1. So you just understand it's there. All right, let's do this one. What's the first thing you might do? Look at the negatives. How many negatives you got?
2.
What's your answer going to be? Positive. So you see, positive answer, okay? Forget about that. I'm just going to do that. Get them out of there, okay? Now what?
75.
How?
The number going to 12, the number going to 56.
Okay, what would that be?
That's a 6.
6 won't go into 56, I don't think. It will go into 54, but not 56. Okay. 4 I think will do it. Let's see. 4 go into 12. 3 times. 4 go into 56. 14 times. Good. Remember, that's a 14. Okay? Next. 3 up here. We're going to 18 down here. How many times? 6. Okay? So you got a 6 down here. What else? Got a 6 down here. What's that?
3 times 8, 24.
Yeah, but this is a 6 down here. Say again? Yes. 6 will go into 6 1 time, into 24 4 times. I've forgotten what that one was now. Let's see what it is. Oh, we had a 14 down here, didn't we? 14 here, and what did we wind up with up there? See, that's why I like to write them in, but they had all this messing in the way. So let's do it by writing them in. Just ignore that as if I had my arm over it. So what did you say? 4 will go into this 3 times, 4 will go into this 14 times. What was the next one you said? 3 will go into that 1 time, 3 will go into that 6 times, 6 will go into this 4 times. We already took care of the minuses. I'd like to get those out of there. And now all we got is 2 will go into 4 twice, 2 will go into 14 7 times. I forgot to put my 1 down here. Okay? So that leaves us a 2 over 7. There that is. Now let's do the letters. Hopefully I haven't gotten too carried away here. What do you notice will go out in letters? Anything? Okay, why not? Okay, Y and here and a Y there, they go out. Okay? Anything else? Okay. Actually, yeah, you have an X here and an X up there. That goes out. You could put 1s over those. I should probably. Okay. Anything else? Ah, yeah, here's a Y squared. We'll go into Y cubed. How many times? No, Y times. Y to the first, so that would be Y. I think we've got it now. In the numerator, 2x squared, sure enough. Got a plus sign. And in the denominator, just a 7y. See? Real easy to lose that y up there, but that's still a y. This is the disadvantage of doing it this way. The lazy way is easy to lose a factor, get buried in there. It would be 2x squared over 7y. And that's what the answer is. A bit more organized to spread it out and see them a little bit better. You've paid your money, take your choice. Which way you see best and understand best and get right the best. Okay, that's what I want, you to get it right. So, they said first take care of the signs. I think that's a good idea. If rational expressions contain polynomials, these are all monomials. Monomials are pretty easy, right? If they contain polynomials other than monomials that are factorable, then our work may take on the following format. And this is what I say, factor everything in sight. Now, they don't say it that way. How do they say it? Well, here's how they do. What do you think you would do in a problem like this? You got some monomials, but you got some binomials. What might you do? Factor what? X. Okay, the x plus 2 can't be factored, but the x squared minus 4 can be. How does that factor? Anyone know? X minus 2 times x plus 2. You're absolutely right. Now we got everything factored we can. So what do we do now? Just like before, divide out common factors. Do you see any? X plus 2 down here and x plus 2 up here. That's a 1 and a 1. Yeah, a y up here will be 1, and a y down here will go how many times? Yeah, y times, so that just leaves you a y. So what's your answer? 1, good, over y times x minus 2. Okay? Now, the question might be, do you need to multiply that through? I don't see why. I'm lazy. I just soon leave it like that. Could if you wanted to, but no reason to. It doesn't simplify.
What happened with the y?
To what?
How did you end up with
With a 1 up here? Oh, y will go to y 1 time, y will go to y squared y times.
I guess because I didn't see it.
Okay, yeah. Okay. So that's the y, and here's the x plus 2. And in the numerator, all you got are 1s. So don't forget them. They're there. Just not a very meaningful number. Okay. Let's see how they do it. Any questions before I erase it? Okay. See how they do it. First thing they do is write it down again. Good for them. Okay. Then they multiplied them together, but factored at the same time. Oh yeah, I like to take extra steps that are confusing. if you see it, do it, okay? In the numerator was a y times x plus squared, x plus 2, okay? And the denominator had a y squared times, and they factored this, x plus 2 times x minus 2. Why do it that way? Why not do it here? But whatever you see best. And then we notice that y will go into y one time. They didn't write it. They probably should have. Y will go into y squared y times, right? And the x plus 2's 1 and 1. No x minus 2, so you're left with a 1 in the numerator, a y times x plus minus 2 in the denominator. Okay, so the way I did it when I just crossed out this might be a better idea to cross out it all and write the y down here so it's more visible. It's up to you. I like to save my pencil lead or whatever. Okay, the answer being 1 over y times x minus 2. And again, there's no good reason to take it another step and multiply through. Why? It doesn't help anything. It doesn't really simplify it any. So leave it like that. All right, that was example 1. They're skipping example 2 and 3. You want to do them? They're probably a little more complicated than the first one, so let's do them. Here's the first one. X squared minus x over x plus 5 times x squared plus 5x plus 4 over x fourth minus x squared. How would you begin on a problem like that? How? Okay, the first numerator, that's an easy one to factor. How would you factor it? Now, do you like to cross out and write above it or write on the next line? Next line, okay. That numerator would factor as x times x minus 1. Perfect. That numerator is fully factored, okay? Guess what about that denominator? It's not factorable, so write it down, x plus 5. Can't factor that. You got the first one taken care of. How about that second one? Will it factor? Say again? X plus 1 times? You are good, okay? I always check, yeah, x times x squared plus 4x plus 1x is plus 5x plus 4. Yes, you got it right. Okay, anything else? Take out an x squared, okay? And what do you have left? X squared minus 1. Are you through factoring? No, you can factor this x squared minus 1 more time. How does that factor? X plus 1 times x minus 1. I hope you didn't mind if I just crossed that one out, did you? I just didn't want to write everything again. I'm really lazy. Okay. Now, say that one more time. Yeah. You can if you want to cross that out and do an x squared here. That may make it easier to see. You don't have to, but yeah, if that helps you see it, do it. It's fine. Be sure you cross it out there, though. Now what? You've fully factored everything in sight. Now what? Okay, you say x minus 1? Yep, I see 1 up there and 1 down there. Oh, there's x plus 1 up here and 1 down there. Good deal. Okay, x will go into x 1 time, x will go into x squared x times. Okay? What are we left with? I don't think we can go any further. In the numerator, x plus 4 over x times x plus 5. You could write it that way if you wanted to, or you could leave it in factor form. Doesn't really matter. Can you simplify that anymore? Don't even try. Because you can only divide out things that are multiplied. You can't factor them any further. This won't go into this won't go into that. There's nothing else you can do. Don't try to cancel out anything. We don't do that. We divide out things. Right? All right. Let's see how the book did. X plus 4 over x times x plus 5. Perfectly fine, and it would be fine to write that answer as x squared, the denominator of x squared plus 5x. However, if you're doing one of these little packages like WebAssign and stuff like that, if you don't give the answer they'll put down, they'll say it's wrong even though it's perfectly right. So that's why I don't like messing with them. But that's my bias. You shouldn't be affected by that, except that I don't use it. Okay, next. I should have asked, were there any more questions on that one? I can't get it back, but if there were, I'll try to reproduce. Here's the next one. 6n squared plus 7n minus 5 as a numerator. Denominator, n squared plus 2n minus 24 times new numerator, 4n squared plus 21n minus 18 over 12n squared plus 11n minus 15. Let me remind you of something. How do you eat a 5,000-pound elephant? One bite at a time. Absolutely. Don't get overwhelmed by these big, hairy-looking polynomials. Take them one bite at a time. What little nibble would you like to do first? Okay, you're starting with the numerator because you're a hard worker, right? Okay, I look for the easiest one to factor. And where is it? I'm lazy. I'm sorry. Okay? No, I'm not. Okay? Which of those you think is easiest? Now, the first thing I look for, are there any common factors that make some of those numbers smaller? I've already looked. No, no, no. Okay, so no common factors. So which one of those is easiest to factor, you think? Why not this one? Okay. Oh, you said it?
I thought they did.
Yeah. This is it, because look, it's n times n. I can do that one, okay, pretty easily. How do you factor that? N times n, okay. Where do you look next? Sign of the last term is negative, so that means these two signs are? Say again? No, if that's negative? Yeah, plus and minus, okay? Now, because they're different signs, you're looking for two numbers that multiply to be 24, but whose difference is 2. 6 and 4, and which one gets the plus, which one gets the minus? 6 gets the plus because plus wins, 4 gets the minus because minus loses. Okay, so I got on that one factored. That wasn't too bad, was it? Okay? Now here's what I do next. I cheat like crazy. Okay? I look at these and say, does it look like n plus 6 will go into that? Well, the n's no problem, but 6 won't go into 5, so hang that one up. Does the n plus 6 go into that? Well, n will go into this, and 6 will go into 18. So guess what I'm going to try first? I'm going to see if I can factor this one and hope to, no guarantee, but hope that one of those factors is going to be an n plus 6. Because I want to get rid of it, right? Now, if that is an n plus 6, what would this other first term have to be? 4n. You are lazy too, aren't you? Okay. And if that was a plus 6 there, what would the other have to be? A minus what? Woo! Goodness gracious, that messed up. Okay, a minus 3. Y'all are lazy people, aren't you? You saw that right off the top. But there's no guarantee that works. Let's see if it does. N times 4n. 4n squared, that works, okay. N times negative 3. Negative 3n plus 24n, what does that add to? Negative 3n. Plus 21n, look at that, and negative 18. Hey, it worked out. And that, I didn't have to work too hard, did I? Because I'm lazy, okay? Now, I got that done. So, I know right now these n plus 6s are going to go, so go and get rid of them, okay? Now, where do you want to do next? You could have used this n minus 4. Certainly n will go into 6n squared, minus 4 won't go into minus 5. Okay? And those are fractors. Nothing we can do there. Say again? Yes, it will, won't it? Okay? So let's try that. We don't know that it'll work, but let's try it. Let's hope that we can factor this as a 4n minus 3 times something. What would that something have to be? A 3n. You are lazy too, aren't you? A what? Plus 5. Let's see if that works. Okay? 4n times 3n is 12n squared. Okay, good so far. 4n times 5 is 20n would be 11n plus 11n. Fantastic. And this would be minus 15a. I'm happy with that. And now I can get rid of these. See, I'm just getting rid of as much as I can. Now, what else? I sure hope it will. Let's see if it will. 3n plus 5 will go up here. What would that leave you with? A 2n minus 1. Let's see if that works. 3n times 2n is 6n squared. That works. Minus 3n is plus 7n. All right. And this would be minus 5. Yes, that does work. So I'm a happy camper, okay? This 3n plus 5, we'll do into that 3n plus 5. And what do we have left? 2n minus 1 over n minus 4. Can you simplify that anymore? No, don't even try. Okay? Now, that was the lazy way. Okay? If you want to do it a more complicated way, go for it, you know? Okay? Because you don't like cheating, do you? You don't like taking shortcuts, do you? Okay. All right. Now, what do we do with a drunken sailor? No, that's a song. Okay. How do we go about dividing rational numbers? Does anyone remember? What does a rational number mean? Fraction, exactly. How do we divide fraction? What's the rule? Keep the first one just like it is. Rather than dividing, you multiply by the reciprocal. Flip them and multiply. You got it. So you don't need this, but we'll do it. We define division of rational numbers in common fraction form as, again, if A, B, C, and D are all integers, except what you have to exclude. B cannot be 0. D cannot be 0. But hey, we got one more to add. C can't be 0. Why is that? If C were 0, this whole fraction's 0. And that would be this one divided by 0. You can't do that either. So now we've eliminated B, D, and C as 0. They can be positive, they can be negative, they can be any number in the world except 0. But as long as they're not, A could be 0, no sweat. But the others can't. Then A over B divided by C over D. I can remember my 8th grade math teacher she got so tickled when she said she'd say, now she used the time sign here rather than a dot. And she said, this is the bear walking over a log and he gets his feet crossed up and flips over. Silly, wasn't it? Okay, really silly. I'd never repeat something like that. Okay, so what we do is write the A over B. The first one stays the same. The second one changes division to multiplication and flips over. Okay, and then shoot a blue elephant. Have I asked this before? Well, how do you shoot a blue elephant? With a blue elephant gun, silly. I mean, that's what you use, right? So how do you shoot a red elephant? No. Don't go buy a new gun. You swing him by the trunk until he turns blue, and then use your blue elephant gun. You don't need to buy a new gun, okay? So there doesn't need to be a new rule. Just flip them, and then you use the same rule you did for multiplication, because you already know that rule. Don't buy a new gun, okay? All right, never mind. Y'all are crazy. Okay. This definition states that to divide two rational numbers in fraction form, we invert the divisor, that's the second one, and then multiply. And we already know how to multiply rational numbers, right? Well, guess what we do? Well, we're going to do a few. Let's do them. We call the numbers C over D and D over C as reciprocals, or if you like bigger words, multiplicative inverses of each other, okay? I know y'all are going to use that all the time. And why do we call them that? I don't know, but it says because their product is 1, okay? Okay? I guess that's what we call them that. Thus, we can describe the division by saying to divide a fraction multiplied by its reciprocal. Y'all told me that at the very beginning. The following examples demonstrate this. What would be your first step here? 7/8 divided by 5/6. 7/8 stays like it is. Times 6 over 5. And then what do we do? Yep, they showed you. Yeah. Now we look for common factors. 2 will go into 8 4 times. 2 will go into 6 3 times. Nothing else in common, so you're left with 21 over 20. Sure enough, that's it. How about this one down here? What's the first thing you can notice? It's a negative. So write the negatives out there, okay? Then forget about the sign. So then what do we write? 5 over 9, leave that alone. They wrote the negative out in front, which is fine. Times 18 over 15. Very good. And now you look for common factors. 5 will go into 5 1 time, into 15 3 times. 9 will go into 9 1 time, into 18 2 times. And what do you have? Negative 2/3. Don't forget that minus sign. Okay? Not too bad, is it? Okay. Here's another one. What would you do there? First thing right off the top? 2 negatives, so it's going to be positive. What I do is just get rid of both of those, okay? Because it's going to be positive. Then what? Write the 14 over 19. Now, they kept the sign. Why? I don't know, but it's okay. Times 21 over, whoa. Oh, I'm sorry. They did. All they did in the first step was move the minus signs up. What a waste of ink. Okay, no, I didn't say that, did I? Okay? Then that becomes negative 14 over 19 times 38 over 21. And you left off the signs because there are 2 of them. Okay? And then you see that 7 will go into 14 2 times, 21 3 times. 19 will go into 38 exactly 2 times. The 2 minuses became a plus. We already did that. That gives you 4 over 3. Because that's a 1 down. Does that make sense? Pretty easy stuff, isn't it? All you do is flip the second. Okay? They thought it was so easy they shouldn't even give you an example. Shame on them. Okay? Oh, no, I'm sorry. They didn't have. We did all the examples. Okay? Now we're going to move to dividing rational expressions. What you reckon are going to be our approach? Factor everything in sight, but then what do we do? Flip the second one, okay? And you can either flip first and factor second, or factor first and flip second, or get your tongue tied, or whatever, okay? We define division of algebraic rational expressions in the same way we define division of rational numbers. That is, the quotient of 2 rational expressions is the product we obtain when we take the first one just like it is, multiply it by the reciprocal or the inverse of the second one. Okay? That's all we do. And you can either factor first and then flip, or flip first and then factor. It doesn't matter. All right. So we're going to start with monomials. Now, should you start dividing things out? No. You flip first, and then you start looking for common factors. So what do you write down first? 16 x squared y divided by 24 xy cubed times what? 8x squared y squared 9xy. Now, I'm going to rescind that just a little bit. I really find it aggravating that they would write this fractional form that isn't simplified. But they're just trying to make it look complicated. As long as you don't mess with that one, you could simplify that and not mess with this one and simplify that. And there are ways to do that. And then do your thing. But we're going to do it this way because most of the time in real life you wouldn't run into that anyway. Now that you've got them here, what would you do? 8 will go into 24 how many times? 3 times. Very good. And that's about all it for your numbers, right? Because 16 is an even number and the bottom's an odd number. There's no common factors there. What next? Okay. Yeah, you could, but now I'm a little lazier than that. I noticed that, well, yeah, okay. Since you said it, we'll do it. Take that y squared out, and that leaves this to be a y. Why not? And now what? Yeah, then take the 2 y's out. You still got a y over there. That's fine. Next. Say again. Okay, one of the x squares here will wipe out the 2 x's down there. Very good. Okay, I think we've wiped out all we can. So what do we have left? 16x squared in the numerator over, say again? 27 what? Why not? Okay, 27y. Looks like that to me. Let's see how they did it. Okay, let me clear the ink. Is that okay? All right. Now let's see what they did. Yep, they did the first step. Of course, they wrote it again. Good for them. And then they wrote the first one just like it was and changed the division to multiplication and flipped the second. Okay, sure enough, that's just what we did. All right. Once you got it into multiplication, then factor everything inside. Okay. And here we go. Not 16 won't go in any, well, if 8 goes into 24 3 times, that would be a 1 up there. Then you can't do anything else with the numbers. And here we see, now they combined all their x's and made an x fourth up here and an x squared down here. In these cells, that could be an x squared. And if you like to do it this way, do it this way. It's perfectly fine. Up here they had a y cubed, and down here they had a y to the 4th. So y cubed will go to y to the 4th y times. But you see, once I combine the y and the y cubed squared to make y cubed, I'll wipe this one out and just leave me a y. But either way you want to do it. You factored everything you can. You divided out all you can. What you're left with is 16x squared, 27y. Yeah, that's what we got. Let's see if they got it. Good deal for them. 16x squared over 27y. Make sense? All right. That's example 4. Okay. They skipped the next 2. So let's go back and do them. Okay? 3a, see, they completely left off the polynomial part and just did it. So, of course, the one that's most complicated, they leave off. So let's do them. 3a squared plus 12 over 3a squared minus 15a divided by a to the 4th minus 16 over a squared minus 3a minus 10. Yo. All right. Now, I said before, you can factor and then flip or flip and then factor. But because factoring involves more writing, I like to flip first because it just keeps the writing down. And I'm lazy, okay? Not as lazy as Josh maybe, but I'm pretty lazy, okay? So, what would you do first? Okay, but the first one you leave alone, 3a squared. Now, okay, now. Do you want me to get a little complicated with it? It's not really complicated, but guess what? Since we got to write it anyway, you want to go on and factor that top one? And then we'll write it down. Does that be okay? No, we don't have to. Let's just do 3a squared plus 12. This one stays just the same. 3a squared minus 15a. Next, times a squared minus 3a minus 10 over a fourth minus 16. That's a pretty ugly 4, isn't it? How can it be pretty ugly? Okay, never mind. Okay. Now, frankly, when I do it, I factor as I go and flip it as a factor, but let's not. I won't lead you down that path, okay? Because I'm really lazy. I'm even lazier than Josh. Okay. How about that first numerator? Well, actually, I should ask you which one you want to do first. The first one looks pretty easy to me. How does it factor? What? Second, 3 times a squared plus 4, right? That's a squared there, right? Okay, how about that first denominator? That looks pretty easy too. 3a times a minus, did you say? 5. Good, okay. Now, which of these two you want to do next? A fourth, okay. How would that factor, or does it factor? A squared. Second, a squared, you got it. Minus 4 and plus 4, okay. Good deal. Now, you ready for that top one? You want to cheat a little bit? Looking at those on the denominator, will any of these go into that? A minus 5. So let's try that one first, okay? I'm just plumb lazy. A minus 5. Okay? What would that leave you with? A plus 2. Let's see if it worked. We don't know it did. We just were trying to make it lazy. A times A is? A squared. That works. Plus 2a minus 5a would be minus 3a minus 10. Yes, it works. So that one did work. I can cross through that then. Now what? A. Okay. I guess the best question was, are we through factoring? Is that what you're saying?
Oh, no. Wait,
You're not. Why not? That will factor further as, yeah, don't forget that, a plus 2 times a minus 2. Now I think we're through factoring. Because you can't factor the sum of two perfect squares, you could the difference. So we did. So now what? A minus 5 here, a minus 5 there. Done. A plus 2 up here, a plus 2 down there. Done. A squared plus 4 up here. A squared plus 4 down there. Now one more. Yep. The 3s. And that's going to be a 1 and a 1. Okay? You know, we got rid of everything in the numerators, both numerators. So that leaves you with what? 1 over a times a minus 2. I think we got it. Let's see if they got it. Look at them. 1 over A times A minus 2. Good for them. See how that works? Any questions on it? Did I go through any of that too fast? Everybody got it? Y'all are just too quick. What's that?
I was with you up until we start canceling.
We don't cancel, we divide out, don't we? Okay, yeah, okay. Yeah, okay. But you see what we did? Okay, this 3 will go into that 3, so you get lost that one. A squared plus 4 down up here, A squared plus 4 down there too. A minus 5 here, A minus 5 there, we use that. And then when we factor this one more time, you add A plus 2 times A plus 2 over A plus 2, so those go to 1. And you're left with just A and A minus 2 down there, and all 1s up top.
The A squared plus 4, we factored out. One at the top.
We factored it out, but you see we factored it out up here and down here. So those divide out too. Anything over itself is 1. They can go. Good deal. Any other questions? Good question, by the way. Okay, I see some people gathering things up. How are we doing? Oh, no, how could it be? Okay. Okay, that's time enough for me to give you some homework. I'm glad you brought that up. Okay, let me mark where we did. We did example 5. So we'll start with example 6 next time. Let me erase this. Okay. And homework, we almost finished the section. Almost finished it. On page 194, and I think maybe over the 195 as well. Any of the odds 1 through 11. Any of the odds 13 through, 49. Yeah. Now, some of those at the very end, in fact, let me back off from there. Don't forget about 49 or 47. Yeah, so you can do any of the odds 13 through 45. Okay. We'll do those next two after we do the last couple of examples. Okay? Good deal. All right. Now, second? That was all. Okay. This one thing, though. Remember still, if you have looked at Blackboard and haven't seen a grade for your test, that means I wasn't sure if you're finished or not. Okay? If you are finished, let me know and I'll put the grade down. But I don't want to put it down until I'm sure that's the final grade you want. Okay? If you do exceed your grade, it's already there. If you don't, come in and finish those tests whenever you can. Good deal. All right. What's that? You're done? Okay. And I didn't have the grade down there? I thought maybe I did, but let me see. Okay. You know what I think you are? I think you're a snake in the grass. Because you are doing so well in here. You were first of the term was just saying how, okay, so you're happy with that score. Okay. Very good. All right. See, you're a snake in the grass. Okay. You are done with yours? Okay. All right. You're at the first of the alphabet. Let me find you. There you are. Okay with it? You are? Okay. And you're in here somewhere. There you are. Is it? Okay.
I got a class at 12 or 2. What time do you want me to come back? You got a class at 12 o'clock?
Okay. Wait just a second. If I don't do it now, I forget. Okay. Now what's your question?
Do you have a class at 12 o'clock? When do you want me to come back and do mine?
Okay, if you're free at 12, I'll be in class, but you can come in and I'll give you your test. So, let me see. You're at the first of the alphabet, so let me put it in my grade book so it'll be in here. I'll be in class, but come on in. Have you started it?
I have.
Where is it?
I'll redo it.
No. Okay. It may be in my grade book already. Let me see. I don't think it was. Yeah, that light is blinding. These are all math 112. Linear algebra. Ah, there's, no, these are, those. Okay, let me look again. There you are. No, that's quiz 1. Yeah. Quiz 1, quiz 1. I didn't go far enough back. There you are. Okay, I'll move this into my book here. So when you come, I'll have it up here. It won't be down in my office. Okay.
Can I finish now like I did yesterday?
Okay.
In the room up there, or do you?
Were you through?
No, sir.
Oh, you were? I didn't think you were. Okay. You want to do it now?
Is that okay?
Oh, perfectly fine. Is that room open? Does anyone look like
yes,
they're in
sir,
there?
it is.
Yeah, just go right on through.
Hey, my grade's
I'm sorry?
not okay.
Okay. Did you finish?
Yes.
Okay.
She probably
This isn't me.
Oh, I'm sorry. I gave you the wrong one.
I was like,
Okay. I'm sorry.
it's okay.
Wait one. Let me go back. I picked up the wrong one. Okay. That goes here. Duh.
That probably what it was. You know, 5, he thought it was 10. But I did the
Right.
same thing.
There, Kara.
Thank you.
The K's got me all crossed up. Okay. Sarah, I know I'm trying. There you go. Oh, that's your way. Looking for your name. There you are. All right. You want it? Okay. You had left one blank, so I just wanted to. Okay. I want to give you every chance to get it. Okay. I swear, if my head wasn't attached, it would fall off. I'd lose it. Okay. Where in the world is my pen now?
Red pen?
No, my black pen. You see it? No. All right. No, that's the ionizing pen. Yeah, the stylus. That's a pencil. Okay. It's here somewhere. Word. It hides from me. It plays hide and seek. It wants to play all the. I heard it. Yeah, it was. I knew it was doing that. It's a naughty, naughty pen. Okay.
And Mr. Cobb, I had missed the class that I was sick.
Uh-huh.
And when I came back, that back page just, I'm talking about, my mind just went blank on it. And I was trying to see, was there a way that you show more problems or whatever, then I can give somebody a call back up on this.
Okay, well, let me get her right down there before I forget it.
Probably about 4 or 5, 3 or 4 or something.
Okay,
I'm
no,
trying to make a blank back sheet.
okay.
Make a blank.
So, yeah, but what?
Yeah, I was trying to see about the back sheet, the back page, last page.
Oh, yeah.
All the problems on it. I had missed the class before that,
Right.
so when I came back, I didn't know which supposed to do with what.
Mm-hmm.
And I was trying to see if you can let me know, like in the book, what problems would be similar to those,
Okay.
or I can go back then I come back
All
to
right.
that too.
Now, here's a generic answer to that. It won't be specific, but it'll be pretty generic.
Yeah, as long as I can get it.
Because I don't know exactly which problems you're thinking of,
Look
but-
at the back page of one of them tests.
right? Largely, they are from Chapter 6. I can't say they all are, but that's why I said it's generic. And that would be, don't worry about 6.1 at all. All I did was go over that for information purpose, just did the slideshow, but you aren't responsible for 6.1 at all. Okay? So in 6.2, quadratic equations, you can either solve by factoring, okay, or solve by getting in the form of one squared expression is equal to something else, another squared expression, that's that one, or the right triangles, and I don't know, do we have any of those? I don't think there were any of those on the test, were there?
I don't know. 'Cause, like I said, I didn't get to that back page.
Oh, okay. So basically 6-2, then 6-3 is completing the square. And frankly, once you've completed the square, you can go straight to the quadratic formula. So you really don't have to complete the square and the quadratic formula. So it's 6-2, 6-3, and 6-4. I think just about all of them are in those three sections. Okay? Now, you can go to the YouTube videos and see the sections, to the videos that we did on those three sections.
Okay.
6-2, 6-3, and 6-4.
Okay.
And then any questions you have, you can come see me during office hours.
Okay.
The trouble is, I just don't have many office hours anymore now that I do that. On Mondays and Wednesdays, I have 11:15 to 12:15, which is also when I eat lunch, but you can come in there. And then I have technically 5 minutes after my last class, and then I'm supposed to go home, but I'm almost always here after 2. Today, not so, because I got to go to the Birmingham campus. Okay? Tuesday and Thursday, I have from 12:15 until 3:15. That's it, because I'm in class the rest of the day. I've got 3 hours and 45 minutes in the morning and 4.5 hours in the afternoon and evening. So I'm in class almost the whole day, except those 3 hours in the middle. I usually eat lunch sometime in there, but I got 3 hours to do it, so come in anytime you want to. Okay. Yeah, and the YouTube should cover it. And I left off my